Hello students, welcome back to OrganiChemVerse. In this video, I'm going to solve the most frequently asked concept question, that is monochlorination of cis-1, 2 dimethyl cyclopropane. This question either directly or indirectly asked in the exam, and if you learn for one particular molecule like cyclopropane, the principle will apply for cyclobutane, cyclopentane, cyclohexane. So let's get started. The first thing you do is convert the given UPAC name to the structure of the molecule. Start from the root word, that is cyclopropane. So it is a cyclic molecule, and at first and second position there are two methyl groups and they are cis to each other. They are on the same side of the cyclopropane. You can write either above or below, doesn't matter, because both the methyl groups here, they are on the same side of the cyclopropane molecule. So this is one way of representing the molecule. There is another way which you can use, which is also called as wedge dash structure, where the methyl is above the plane is represented by a wedge line, and dashed line represents here hydrogen which is below the plane. Similarly, you can write like this. This is a thick line indicating it is above the plane, and hydrogen which is a broken line which is nothing but it is below the plane. So both the structures are same. Whether you do monochlorination for this or this, you are going to get the same number of isomers. So how to do when you write the structures in different way? For both the representation, I am going to do the monochlorination and help you identify the number of stereoisomers. So during monochlorination, we replace hydrogens by the chlorine atoms. Say for the first structure, we will replace hydrogen from this carbon. And what structure are we going to get? So here the chlorine is above the plane, hydrogen is below, and both the methyl groups are above the plane and hydrogens are below the plane. Now look at the hydrogens, they are all on the same plane. They are below the plane of the cyclopropane. So what does that suggest? That this is a cis molecule. Because this is cis, is there a possibility of getting a trans molecule? Yes, there is a possibility. How so? By removing this hydrogen and writing the chlorine over there. And you should not change the positions of the methyl because methyls are cis to each other. You write methyls either above or below in this structure, but you should not change later on. You have to fix the positions of the methyl. It's just the chlorine which is changing the plane, right? So now look at this. This hydrogen is above. What about these two hydrogens? Below the plane. What is the relationship now? Trans. Therefore, this is a trans molecule. And what is the relationship between these two molecules? They have the same molecular formula, they have the same bond connectivity, but the spatial arrangement of the atoms is different. That means they are geometrical isomers. They are cis and trans molecules. Are they mirror images? No, they are non-mirror images. Although only this part is a mirror image, but methyl in this case both are on the same plane, right? So that means what? They are non-superimposable, non-mirror images. That means what? They are diastereomers. By replacing the hydrogens from above and below the plane, we are going to get diastereomers. Two molecules are formed here. Let's try for these hydrogens now. These two methyl groups are fixed. You write down that as it is first. And the hydrogens here are also fixed. We should not change here. Now, what if we replace this hydrogen by a chlorine? You should keep this as it is. We are going to get a different molecule as compared to this. So here this will become 1 chloro, right? 2, 3 dimethyl. But here it will be 1 chloro, 1, 2 dimethyl. So they are positional isomers basically. These two are not same molecules. They are positional isomers. What if we remove from here? Is it the same molecule or different molecule? Of course, it is a different molecule. Although these two carbon look similar. They are different in nature. How so? Let's prove that. If I remove from this position, you are going to get a different molecule. Then what is the relationship between these two molecules if they are different? The relationship is they have the same molecular formula, but they are non-superimposable mirror images. What is this definition for? It is for enantiomers. Therefore, they are enantiomers. And observe this, both of them are on the same plane. That means it is cis. Both are cis molecules. So they are not exhibiting any geometrical isomerism, right? Therefore, the relationship between these two molecules is enantiomerism. And how many we got now? We got two. This is the other possibility. We can remove from this particular carbon. Again, you might think that these two methyls are in the chemically equivalent positions. Therefore, by removing either this hydrogen, you will get the same molecule. That is wrong. Why so? Again, let's just write the structures and then you will get to know. Here you keep the methyl as it is, right? Again, when I remove from this, what are we going to get? CH2Cl and here CH3H. Look at the structures of these two molecules. Again, they are non-superimposable mirror images. That means what? They are enantiomers. So how many molecules we got now? Two molecules. We have all together, there are 6 isomers possible for the monochlorination of dimethyl cyclopropane molecule. Many students, they think that we can just write the structure of cyclopropane like this and then we will do the monochlorination. I don't think you will get the right answer if you do this. It's always better to elaborate the molecule like this and then replace the hydrogens and then check for the relationship between them. Are you going to get the identical or enantiomer or diastereomer? Based on that, you can count the total number of isomers. Let's see how to do for three-dimensional structures. The reason why I am explaining monochlorination again for three-dimensional structure is you can expect such three-dimensional or wedge-dash structures in the exam and you should not fail to understand the structures. That is the only reason, and many of my students have asked this question to me. That's why I thought it's better to explain it. Now, all you have to do is just replace the hydrogen. So here, what you have to do, one, you have to write above and below the plane. Are these two non-superimposable, non-mirror images? Yes. Therefore, these two are diastereomers. So we got two structures. Fix these two as it is. Now, look at this. You have to replace the hydrogen here by chlorine. And what about here on this carbon? Like this. And what is the relation now? They are non-superimposable mirror images. This way, it's very easy to understand whether they are mirror images or not. One thing. The next thing is you can always do R and S configuration also. See, for example, for this carbon, if you want to do R and S configuration, say let's assume if it is R, then this will be S. And if this is S, then this will be R. So that shows that they are enantiomers, right? So that is the reason. Now, for this, what you have to do, change the position of the halogen. Say CH2Cl here, CH2Cl here. And again, they are non-superimposable, non-mirror images. They are diastereomers. All these four are cis only. There is no possibility of trans. Hence, we are going to get 6 isomers. I hope I made this clear to you. And if you still have any questions, you can drop your queries in the comment section. Meanwhile, you can try for the trans 1,2-dimethyl cyclopropane as well. Thank you for watching this video. Until next time.